In this video, we are going to take a look at homework 11A. But before you get started on homework 11A, be sure that you have reviewed the materials in 2.4 proofs. As usual, there's a guide to this module. There's a schedule with a breakdown of what to do this week, and your task for this week is to watch the 3 lecture videos before you get started on this homework assignment. And those lecture videos are down here in the materials. So here's lecture video 2.1, 2, and 3. Introduction to the method and an overview of the 5 basic inference rules. Once you've watched those videos, let's get started on the homework. Okay, so be sure to read all the parts. I'm going to go through this homework with you, but you'll want to pause and complete the homework on your own and read all of the parts. I'm just here to introduce the different questions and give you some tips. Okay, so be sure to pause right now, read the various definitions, and take a look at this example. So here's a passage which we have applied Unit 1 skills to in order to clarify the passage and reconstruct it in standard form. We're applying Unit 2 Mod 2 translation skills in order to put this into symbolic notation. We have the counter example method for showing that the argument is valid. We have the truth table method for showing that the argument is valid, and you should select whether or not it is valid or not, and hint, this one's valid. What is the reason why? Use the table and select the reason why. And now we're going to look at the proof method for showing that this argument is valid. And if you've already watched the videos, you've been introduced to these rules. So here's a reminder. Again, there are 5 rules. There are just 3 here because these are the 3 rules relevant to this first example. When we have completed the proof, it'll look like this. So this was our original argument. Let's go back and just see that that's true. See, here's our original argument. And what we did was we took the conclusion, P and B, and we moved it up to the side. This is the thing we need to prove follows from the premises. And we'll do it row by row, showing that if these premises are true, then P must be true. And if that's true, then B must be true. And if all of that's true, then P and B must be true. To get P, we look at what? How do you get P? Pause a moment, explain it to yourself. As indicated, because this proof is already completed, as indicated, we're looking at rows 1 and 2, or lines 1 and 2 rather, and we can see that line 1 is a disjunction, line 2 is the negation of the first disjunct, and so we can infer the second disjunct. And we justify our doing that by citing the lines that we looked at and the rule, disjunctive syllogism, which we abbreviate DS, and we're just going to put abbreviations in when we construct the proof. Now that we know that if 1 through 3 are true, P must also be true, how do we show that then B must be true? Well, we have on line 3 a conditional, and now we have the antecedent of that conditional on line 4, which means by modus ponens, citing lines 3 and 4, we can infer B. And now that we've shown that if the premises are true, P and B are true, we can use the conjunction rule to say that the conjunction of these 2 things we've shown to be true must also be true. And we'll cite the lines 4 and 5 and conjunction rule. Now, you're going to have auto-graded questions, so the formatting is important so Canvas knows how to grade what you're doing. Be sure to put a comma between line numbers, not a period or nothing. There needs to be a comma between line numbers, and don't put a space. It'll still accept it if there's a space after the comma, if it goes 4, comma, space 5, but my examples don't have a space. But technically that's what it'll accept. Make sure the line numbers are in numerical order. Does this matter logically? No. What the point of these numbers is to tell us which lines we looked at. So if you cited lines 2, 1, that's fine. We looked at lines 2 and 1. But for Canvas grading reasons, numerical order. Don't spell out the names of the rules. Just use the abbreviations, again, because of auto-grading. Same with unnecessary parentheses. And then to get the symbols, you can either copy and paste from the original setup and put them into the boxes, or if for some reason you're having trouble copying and pasting, use the ampersand instead of a dot, or this symbol instead of the horseshoe. Capitalization doesn't matter for formatting. So here's that same one. So let's go through this one together. First, you might pause and do it on your own. Don't scroll back up and look. Pause, do it on your own, step by step. If you've already paused and finished it on your own and you got it, fast forward. If you didn't feel confident or you were unable to get started without scrolling up and looking at the answer or turning on the video, well, let's think through it, think aloud style. So I know every time that the thing I'm trying to derive, my last line, is going to be the conclusion. In this case, it's P and B, so I just copied and pasted it down here. Now I don't yet know how I'm going to get the conclusion. I just know I'm trying to get P and B. And since I know it's a conjunction, I don't know for sure. There's not an algorithm that tells me how I'm going to end up with this conjunction, but one idea I have is I might end up using the conjunction rule. So my strategy is if I can get P and B on their own lines, I could use the conjunction rule to get them together. And because we just saw this one above, I know that's how it turns out. But that's not necessarily the only way we could end up with it. Like, if this was the consequent of a conditional, maybe we use modus ponens to get it. But I see that it's not the consequent of any conditional, neither is it part of a disjunction, such that I could separate it out of a disjunction. So I'm thinking my strategy is to get P and B on their own lines. So let's just start with thinking about P. Where does P show up in the premises? It shows up as the antecedent of a conditional. Can I get P out of a conditional? Well, sort of. The only rule that would allow me to do that is modus tollens. If I had not B, then I could get not P on its own line, but I don't want not P, I want P. So that's not promising. I also see P is up here. P is part of a disjunction, and I know that disjunctive syllogism is a way that I can get one of the disjuncts on its own line, if I have the negation of the other disjunct, and I do. So I can get P on its own line, citing lines 1 and 2, and the rule disjunctive syllogism. Now the other thing I need to get on its own line is B. If I can get this, then I can get P and B by citing lines 4 and 5 here, and the conjunction rule. So I'm kind of like working forwards and backwards because I think this is my strategy. So how do I get B? Well, where is B in the premises? It's in a few places, but the thing that really sticks out to me is that it's the consequent of a conditional, and that sticks out to me because I know that modus ponens is a rule that allows me to get the consequent of a conditional on its own line if I also have the antecedent on a line, and I do. We've already shown that if these premises are true, so too is P. So now that I have the conditional and the antecedent on a line, I can infer the consequent. I will justify that. I looked at lines 3 and 4, and I applied modus ponens. Okay, so the next couple of questions are practice with rules. Yours might appear in different orders, FYI, so you might need to scroll up or down, whatever, or you might have different rules, but here are the ones that show up when I take it. So, modus ponens. Reminder of what the rule says you can do, what you need to have on lines in order to get a new thing. And it'll ask you which of the following are examples of arguments that have this argument form. And there's 2 correct answers. So modus ponens says if you have a conditional, and notice premise 1 for all of these, first 3 are conditionals, but this one isn't a conditional, so this one's automatically out. Modus ponens says if you have a conditional and the antecedent, you can infer the consequent. The main operator is not a conditional here. You might be thinking, wait, there's a conditional here. I've got a conditional, and I have the antecedent, so I can infer the consequent. This is a common error. It's only if the main operator is a conditional that modus ponens applies. If you want to get this and use modus ponens on this, you need to get this on its own line first. If this were a longer argument and we had not P on a line, you could use disjunctive syllogism to get this on a line, and then you would have then you could apply modus ponens. But as is, this one's out. So we've got 3 where the conditional is the main operator, but the other thing you need is the antecedent on its own line. So number 1 here, notice you've got exactly the antecedent, and it's inferred the consequent. So this is an application of modus ponens. What about this one? Do you have the antecedent on its own line, thus that you have inferred the consequent? No, it's backwards. This is not modus ponens. What about this one? Do you have the antecedent of this conditional on its own line? Yes, you do. Did you infer the consequent? Yes. So this is an example of modus ponens. And this one will throw people off because there's a tilde involved. The schematic for modus tollens has tildes in it, but looking at tildes and schematics can be confusing. What modus tollens says is that if you have a conditional and you have the negation of the consequent on a line, then you can infer the negation of the antecedent. That's different from just having tildes in certain places. Modus ponens says if you have a conditional and you have the antecedent of that conditional on its own line, and we do, the antecedent just happens to be a negated statement, then you can put the consequent, whatever it is. In this case, it happens to be a conjunction. So that's the basic idea, and you'll want to do this for other kinds of questions here. So disjunctive syllogism, again, you'll be looking for common mistakes, only applying it to part of a line, and confusing tildes versus negation, having the negation of something. So here's modus tollens, same idea. And then you'll have 3 proofs. So question 6, question 7, question 8. You'll have 3 proofs to do, and yours might not be the same as mine, but they'll be structured similarly. It'll be a very similar kind of proof. So let's do a quick think aloud just to get started on these proofs. Of course, you should pause and try it on your own first. But if you get stuck, turn it back on and we'll do it together. Okay, so how do I get started here? Well, I know what the last line is going to be. I don't know how I'm going to get it, but I know it's going to be x. How do I get x? My first step is to sort of just look for it in the premises that I have, and there's sort of 2 strategies here. I've been doing a think aloud work backwards, kind of reasoning backwards. I know I'm trying to get to x, and where is it? So that's one strategy that you could do, and I'll do that first. The other strategy is just apply any rules you see. And that's usually going to work for simpler examples. But if we're reasoning backwards, I want to get x, and I see that x is part of a disjunction where one disjunct is a conditional and x is the consequent of that conditional. I know that modus ponens is a rule that allows me to get the consequent of a conditional on its own line. So I'm guessing that if I could get this bit on its own line, then, and if I had q, and hey, I do, then I could use modus ponens. So my goal is to get this conditional on its own line. Can I? Well, it is a disjunct that is part of a disjunction. And I happen to have the negation of the other disjunct. So I can, by disjunctive syllogism, I'm going to copy and paste this. By disjunctive syllogism, I can get this on its own line. I'm going to cite lines 1 and 2 and the rule ds. Now it's one step away from getting to x. If these are true, then this conditional has to be true. So now I have the conditional and I have the antecedent that allows me to infer x. How? Cite the relevant lines and provide the relevant rule. Let's move on to the next one. So again, I just immediately know this is going to be the conclusion. So the question is how do I get to it? Oh, I said before that there were 2 strategies, the working backwards or the try anything. You might have just immediately noticed, hey, I have a disjunction and I have the negation of the antecedent, or of the first disjunct, rather. There are no antecedents in disjunctions. And you could have just immediately started there, and then just see that modus ponens applies. Just seeing things you can do and trying it is often a good strategy for simple proofs. But when they get more complex, being able to work backwards and see patterns is helpful. So I'm going to just sort of practice this with these easier questions. Okay, so I have a conditional. A is part of that conditional. What is it? I'm going to just use the jargon, right? So it is part of the antecedent. And in particular, it's part of the negation of a disjunction. Since I want to get something that's part of the antecedent on its own line, I'm immediately thinking modus tollens, because modus tollens says you can get the negation of an antecedent on its own line if you have the negation of the consequent, and we do. So what's the negation of this antecedent? What's the negation of not A or B? Well, the negation would be just plain A or B. Alternatively, it would be not A or B, but we don't want that. So I know that I could do this. I could get A or B by looking at 1 and 2, modus tollens. And that's useful to have because that's a disjunction, and I know I can get a disjunct out of a disjunction if I have the negation of the other disjunct. And I do on line 3. So what will I cite to get to A? Which lines and which rule? And again, new question. No, we're ultimately going to get to not Z. I'm not going to fill in any more of the boxes here, but maybe do a bit of a think aloud. Again, pause, do it on your own first. But if you want to think aloud together after you've had a chance to try it on your own, let's do it. So I know I want not Z. I'm going to start by looking for where the letter that I ultimately want not Z, and it's important that you've got the tilde in front. But I'm just going to look where Z shows up because tildes come and go with rules. And I see that Z is part of a conditional. In particular, it's part of the antecedent, or it just is the antecedent of a conditional. I know that there's a rule that says I can get the negation of the antecedent of a conditional on a line, and that's what I want, the negation of this antecedent. What rule is that? It's modus tollens. What do you need in order to use that rule? You need the conditional, and you need the negation of the consequent. What's that? Not X. Do we have not X on a line? No. It needs to be on its own line. The fact that it's part of this line is irrelevant. You need to have not X on its own line. So my new strategy is, how do I get not X on its own line? Well, let's describe what it's a part of. Right now it's a part of the consequent of a conditional, and it's part of a disjunction. But let's worry about the fact that it's the consequent of a conditional. There's a rule that allows me to put the consequent of a conditional on its own line. That rule is modus ponens. If I have a conditional, and I have the antecedent of that conditional, I can put the consequent, and we're not going to include parentheses. We're going to leave off parentheses when they are not necessary for ambiguity reasons. So I know I can get this on its own line. Once I have this on its own line, not X is part of a disjunction. I can get a piece of a disjunction onto its own line if I have the negation of the other disjunct. That I've got. So I'm seeing my strategy crystallize. First I use modus ponens to get this on its own line, and then I use A again as part of disjunctive syllogism to get not X on its own line. There's nothing that says you can't refer to a line more than once. Once I have not X on its own line, I have what I need to apply modus tollens to get not Z on its own line. Okay, and then finally, read the study advice. The study advice is important. Good luck.